sum and difference identities are probably the scariest looking formulas on your formula sheet, but they are actually very easy to use. Okay? First of all, they're scary because they have two angles in them. So normally when we had our formulas up to now, we had the angle theta. You're probably most used to this Greek letter for angles, right? Now, when we have two angles in something, it's like, oh, they should have just used theta and something else, but they decided to use two new Greek letters. They are alpha and beta. So if you have two angles added inside of sine, the following formula takes place. That sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. We're not going to prove where this comes from right now. We're just going to say thank you to the math gods for giving us these formulas, and we are going to learn how to use them. Okay? Number one mistake that students do, and I'll write it in red here, is sometimes they see this, sine alpha plus beta, and I'm going to put a big, this does not equal, but they're like, oh, when I have something outside of brackets, I distribute. So they want to write sine alpha plus sine beta. As soon as you do that, all your work after this point will get 0 marks. So if you start off a question with a sine alpha plus beta and do this, you're basically saying, I would like to get 0 on this question. Because this is not true. You are allowed to distribute if this is a number. But sin is not a number. It's a function. It does something. It's in the same, here's another example of something you're not allowed to do. If you are adding, say, 9 plus 16, can you do the square root of 9 plus the square root of 16? Are you allowed to? No, because the square root is a function. It does something different. This is also not equal to each other. You can, that one, you can even do the math. 9 plus 16 is 25. The left-hand side should be 5. Square root of 9 is 3. Square root of 16 is 4. 3 plus 4 is 7. 5 is not equal to 7. So if you have two angles added inside of each other, you are not allowed to distribute the sign. The only thing you would be allowed to do is use one of these formulas. And you don't have to have these formulas memorized. They're given to you on your formula sheet. Okay? Here's a good example of why this doesn't work using our pi plates. Okay? You remember what sine of 30 degrees is? And you remember what sine of 60 degrees is? So if I write 30 plus 30 inside the brackets, this is basically sine of 60 degrees. And sine of 60 degrees from our pi plate is root 3 over 2. If I wrote sine of 30 plus sine of 30, these are also on our pi plate. Sine of 30 is 1/2. Sine of 30 is 1/2 again. Sine of 30 plus 30. Sine of 30 plus sine of 30 would be 1/2 plus 1/2, which should equal 1. And again, 1 doesn't equal the square root of 3 over 2. But apparently, if we wanted to, we could use a formula here and say, this is alpha and this is beta. So sine of 30 plus 30, according to the formula above, would equal sine of 30 cos of 30 plus cos of 30 sine of 30. So what I've done here is this is alpha, this is beta. Alpha I have used this very first formula and just replace things in the formula with the numbers. Now, I would highly recommend that you would just do 30 plus 30 and get 60 and know that that's root 3 over 2. But if you wanted to, we can check to see if this formula at least works. Sine of 30 is 1/2. Cos of 30 is root 3 over 2. Plus cos of 30 root 3 over 2. And sine of 30 1/2. And if I multiply these together using my fraction rule, this will be root 3 over 4 plus root 3 over 4, which I have a common denominator, so I can add them. Adding the tops would give me 2 root 3s over 4, and this reduces to root 3 over 2, which is the same as if we had just done sine of 60 to begin. Of course, you would never want to use this for sine of 60 because you already know that value. But there are going to be some times where it's going to be useful to use these formulas. And we're going to start with example number 2. Sorry, the order today is not going to follow 1, 2, 3. We're going to do them in a bit of a different way. So starting with example 2. Oh, and before we go to example 2, I'm also going to show you. So we have formulas for sine and cos. There are also 2 formulas for tan. They're listed on page 638. And all 6 of these formulas are on your formula sheet. So for example 2, one of the things that you have to get good at in this unit is recognizing when a formula is present and being able to switch either from the left side of the formula to the right side or from the right side of the formula to the left-hand side. You don't have to have your formulas memorized, but you have to have them mostly memorized so that you can recognize when should I look at my formula sheet. And this would be an example. Okay? Write each expression in simplest form, evaluate where possible. So in A, I see sine cos minus cos sine, and I'm like, I have a bunch of formulas that have sine and cos, and some of them are adding and some of them are subtracting. So I want to check if there's a formula where I have a sine alpha cos beta, cos alpha, sine beta with a minus sign in between. So I look on the right-hand side of my formulas, and I notice this one matches up perfectly. And it has to match up perfectly in order for you to do a switch. So since this matches up perfectly with the sine alpha minus beta formula, I can say that this is equal to sine, and again, so this is alpha minus beta, and here's alpha, beta, beta. It matches up perfectly with that formula. And then because these are like terms, I could simplify this just to be sine 5x. In part B, I can evaluate tan of pi over 6 because it's on my pi plate, but tan of pi over 12 is not on my pi plate. So then I notice I have a big fraction with a bunch of tans, and this is where I would say you have your formula mostly memorized. You'd say, I have a couple formulas with big fractions with a bunch of tans. Does that match up perfectly with any one of these? 10 plus 10 over 1 minus 10, 10? Yes. So this would be, we look at this, I make this my alpha, and this my beta, and this alpha, and this beta. That matches up perfectly with tan alpha plus beta. So I can rewrite this one as being equal to 10, alpha was pi over 6, and beta was pi over 12. I would get tan of pi over 6 plus pi over 12. If I get a common denominator by multiplying both of these by 2, I could write this as tan of 3 pi over 12. And tan of 3 pi over 12, that reduces to tan pi over 4. Now test your mental math skills from your pi plate. Do you remember tan pi over 4? Is 1. So this one we could evaluate. And circle the questions 4 and 5.